Good morning, good afternoon to everyone, and welcome to the Go Native with Spring Boot 3 and GraalVM session. For today, you will learn what is native Java, why is it important to you, and of course, how it can help you. That was all on my side. I would like to invite Ewan to the floor now, and of course, to wish you to enjoy the session. Ewan, the floor is yours.
Thank you, Violetta.
You're welcome.
So my name is Ewan Slater. I'm currently the Technical Director of Product Marketing for Java and GraalVM. I joined Oracle in 2005 when they acquired Thor, and I've been working there since, focused mainly on Java technologies and cloud technologies. I've been working with Java myself since 1997. So the session today, I'm going to go over the compilation of some executables. And then we're going to have a bit of a discussion. I'm going to talk about what is native Java, why does it matter, why does it matter to you, why does it matter now, talk a little bit about Spring Native, which was the project to integrate native Java with Spring, and then about Spring Boot 3. And then I'm going to compare the results of running native Java with standard Java for a very basic web application. And then we're going to finish up with a summary and some suggested next steps, things that you can do. As Violetta said, you will have access to the trial account. What I'm doing today, I'm running in a VM that's running on OCI infrastructure. It's one of our ARM VMs, so you could, for example, run one of those VMs as your development environment. Now, every cookery book that you read, pretty much, if it involves the oven, this is the first instruction or something like it, because we want to use our time efficiently. And if you've been around IT for as long as I have, you will have certainly at some point in your life have started out with compilation. When I was at the beginning of my career, compiling could sometimes take an hour, two. You'd time it so it would begin at lunchtime, or sometimes it would even run overnight. And one of the things about native Java is that there is an increase in compilation time. So what I want to do is to start with the first half of the practical exercise, which is to actually get the compilation going. And then I will talk about the ideas behind it. And then hopefully at the end of that, we will have finished the compilation and we can look at the results. So, okay. Right, okay. So, I'm going to create a Spring project two ways. And the key part for native Java is to put native as one of your dependencies. The other dependency I'm going to put is web. And there's two ways we can do a build. We can do it with Graal, and we can do it with Maven. So I'm going to show you both. Then we're going to to the Maven one. So let's call it Mike instead. Okay, so it's got two directories there. Let's go to off the first one. So to kick off our native build, we do that. And that will kick off, and it will take a while to complete. Let's another one. That one should kick off. Right, so those will take a little while to run. So rather than spend our time watching those, let's go back to the presentation. So native Java, in a way, I think of it as bringing things full circle. And when I first started out in IT, so we're talking 1993, 1994, I was programming in Fortran. I was using a VAX VMS system, and also then started programming in C. Never actually did C++, but that led into Java. And if you wanted a program to run on multiple platforms, you had to do cross-platform compilation. You had to write your code, and then you had to compile it to run on each of the different target platforms separately. And so if you were using C, for example, you had to make very, very sure that you were only using ANSI standard C, because that way things would compile, hopefully, on all of the platforms. And, you know, it was all very nice in theory, but in practice, you know, working cross platforms was always a bit of a pain. And it was enough of a pain point for all of us that Java came along, and we all thought this was brilliant, because now, instead of writing our code and having to compile it on each separate platform, you would run Java C, you would compile your Java code, it would compile to bytecode, and then it would go and run on a Java virtual machine on any of your platforms. And it was then the responsibility of the platform owner to create a Java virtual machine that met the standard and would run any piece of Java bytecode. So that was great. Initially, Java was slower than C code, and then we got into things like just-in-time compilation. So as the Java code's running over time, the compiler or the VM will work out which bits of the code can be usefully compiled to native code. But now the environment that we see today is a lot more homogeneous than that we used to see in the past. Pretty much everybody that I've worked with for a decade runs their production workloads on x86 or ARM and Linux. So now we've come full circle. Now we have our Java code is compiled to Java bytecode, and then there's a further compilation step which will compile it to native code, which will then run on the target platform, typically Linux these days. And so we're now doing native compilation. We are now going back to essentially producing machine code at the end. With the with the build stages I showed you before, you can, if you want, you can do a separate Java compile, and then you can do a native compile of the jar file that's kicked out. But it's nicer with the tooling that you just do it as a single command. And the net result of this is that we get a runtime artifact that is faster and leaner than the compiled Java code, whether it be just class files or a jar file that we had before. So this was a result that came up at Spring 1 a year or two ago, and some of the people working with the Spring Native project. And they'd taken the traditional Spring Boot pet clinic example, and they'd compiled it just with the JDK, and then they'd compiled it to native Java as the native executable. And they were comparing, how long does it take to build, how much memory does it consume, and how long does it take to start up. And as you can see, the build time for the native executable is considerably longer than the build time for just the JDK. But the memory consumption, 75% less, and the startup time, it's 94% quicker. So clearly that's a major saving in terms of the resource consumption, in terms of your startup time, with the trade-off of a longer compilation stage. And it's not just the amount of memory that's being consumed, it's not just the amount of CPU that's being consumed. If you're containerizing your application, if you're using a native image, if you're using native Java, you can produce a much smaller container. So if we take the example on the left, so this is the traditional way of doing it. You've got your Java application, you're packing in the whole of the Java runtime environment, you've got the operating system all within your container. Now, we can minimize that slightly with using JDeps and JLink, so then you'll ship just enough of the Java runtime environment for your application to be able to run. But if we go down to a native image, and we go down to what's called a distroless container, which has just enough operating system within it, what you will get to look at then is a much smaller container with much less in it. And that has advantages in terms of portability, in terms of storage consumption, and in terms of security. So why does it matter so much today? Why does it matter so much today, making things faster and leaner? Because you could argue, if that had always been the situation, we might never have gone through the whole Java interpreted bytecode thing. And I think one of the key drivers here, one of the key drivers today is cloud. Now, a company that I worked with a couple of years ago, they had an on-premises solution, and they wished to start offering that as a cloud SaaS service. Now, they thought initially it was just going to be a case of, we'll put it onto virtual machines and we'll run it in the cloud and we'll give our customers access and we'll be very happy. And then when they saw the actual cloud bills coming in, they were like, oh, this isn't viable. And what they discovered was that turning an on-premises application into a SaaS application is not just a question of rehosting. Their original architecture is on the left-hand side. You can see that they had a VM, within that VM, they've got a monolithic application. And if they wanted to scale out one part of that application, they had to stand up a whole new VM. And this was an inefficient use of resources. When they were running on premises, it didn't matter because the application owner, the person who was consuming it, was just basically paying for a license, and this was their recommended deployment model, and they'd already paid for the hardware, or somebody else was paying for the hardware. Now in cloud, you're paying for all the resources that you're consuming, and you're paying by the second or by the hour, depending on how you build. So it became much more important to have a more agile architecture. So that's what you see on the right-hand side there, where I sat down with their CTO, their lead developer, and helped them re-architect the system into a set of microservices that could be started independently. So in terms of cloud economics, and economics drives your architecture, or if you try to do architecture without regard for the economics, you're not going to be in business very long. You need to minimize your infrastructure. You need to only run what you need, and you need to only run it when you need it. And this leads us to cloud native. And cloud native is about building loosely coupled systems that, as the definition says, allow you to make high impact changes with minimal toil. And native image, native Java is a really good fit for cloud native. We can do smaller runtimes. We go from a big jar down to a small binary. That means we can build smaller containers, and containers are the de facto standard artifact that people are using in terms of cloud native. We create these distroless containers. They have a reduced attack surface because there's not much in them. It's easy to know what vulnerabilities your container has. You'll have fewer of them. And if you find that there is something that needs to be changed, you're only changing those containers, not a whole load of them. Then in terms of resource utilization, you've got a faster startup time. You don't have a period of time while your JVM's spinning up, while it's getting warmed up, while its performance is accelerating. You have lower latency for responding to customers' needs. You are able to scale out quicker, you're able to scale back, and you lower the memory usage. You also lower your CPU usage typically. And what all of that leads to is lower infrastructure costs, which is what you, as someone who is trying to create a cloud solution, that's what you want, because if you can lower your infrastructure costs, you're more cost effective. So, is native Java a silver bullet for how we do Java in the cloud? No, there are no silver bullets. As far as I'm concerned, there are only double-edged swords. And so with any technology, there are trade-offs. And the important thing is that we make those trade-offs consciously. That we as architects, as developers are going, I'm aware of what the trade-offs are, and I know they make sense for me or for my business in this particular use case. So there are some limitations around the use of native image. And mostly they revolve around the closed world assumption. So traditionally with Java, you've been able to do things dynamically. You've been able to load classes at runtime. You've been able to do configuration. You've been able to do dynamic class loading. And when you are, and that hasn't mattered because you've been interpreting and compiling as you're going along. When you're doing ahead of time compilation, the compiler has to know everything it's going to need to know about to put into the executable at compile time. So obviously, if there's a class that it doesn't find when it statically analyzes the code, that isn't going to be included in the executable. Now, there's a couple of things that we can do to get around that. One of the ways is we can do tracing. So you run the application in JIT mode, and you have tracing on, and you find, hopefully, all of the classes that are needed at runtime. And then that gets gathered into a configuration file that's passed to the compiler to say, you need to go include this stuff as well. You're not finding it on static analysis, but you need it. There's also the option of manual configuration, if you know, without needing to do the tracing. And there is also what we're calling a metadata repository, which if you're using particular libraries, you can just reference that and the correct configuration information can be passed to the compiler. One of the consequences of this is that retrofitting native image to existing code bases can be hard. And it depends what libraries those applications use, and do they do any dynamic loading at runtime, and it depends on how you've written your code. So you may have older programs, existing programs that can be compiled to native image easily, but be aware that some existing code bases, and the larger they get, the greater the the chance that it becomes difficult. So retrofitting it can be hard. The other thing I would say, based on my experience, is to know why you're using native image. I have come across a couple of cases where people have said, I'm putting my bytecode into an area where I'm worried somebody might reverse engineer it. So I'll compile it to a native executable as an obfuscation tool. There are better tools for doing code obfuscation, and I wouldn't use native image for that. So there are trade-offs with the use of native image. I think it's best the easiest way to use it is when you're doing new development, building things like microservices, building things like serverless, where again, avoiding cold start or minimizing the impact of cold start is important. And the other thing I would say is that if you're wanting to build towards native, or you think you might want to be using native Java, then I would, as part of your development pipeline, I would start doing compilation to native from the start. Yeah, so don't go and build an application and then find you put in a load of stuff that's say dynamic, and you then need to work around that. Start compiling to native from the beginning. Flush out any issues along the way. So, Spring. Most of you probably work with Spring or have worked with Spring in the past. It's one of the most commonly used frameworks. So a couple of years ago, the Spring Native project began, and the idea was to allow Spring applications to be created as native images. Now, Spring Native works, but it is, as it describes itself, an incubation effort. So it is tied to Spring Boot 2.7.7. You have to work with a bunch of plugins. You have to set up particular toolkits. It's a bit fiddly. So it works. I've used it. Other people have used it. The guys who were doing the results I showed earlier were using that, but it's not necessarily easy. So, early Christmas present that the Java development community got in November was Spring Boot 3 became generally available. And I've highlighted the this thing here. which is that the support for generating native images with GraalVM was now included out of the box. And that's why when I created the projects earlier, all I had to say was that I wanted native image as a dependency, and Spring takes care of the rest of that with Spring Native. Now, if you want to include Spring Native in your project, you can go to Spring Initializer, you can add your dependencies. You need to make sure you choose the GraalVM native support, and then you will see that in the developer tools. And then you can download that and generate that project, and give you a zip file, and you can install that and run that. Or you can install the command line, Spring CLI, and then do it this way, which is the way that I prefer to do it myself. But I prefer typing to UIs generally. Again, the key thing is that you say in your dependencies that you want to include native. And once you've done that, you're then able to, with a single command, GraalW native compile, you're able to build the native executable, or with Maven, it's Maven WP native compile. And in both of those cases, on the machine that I'm using, which is, it's an ARM VM in OCI with 4 OCPUs, it takes about 4 minutes to run. And so that will take, if you run them in parallel, about 8 minutes. So we have come full circle again, because now we're going to go back to the terminal environment and look and see the results of what's happened. So, right. So you can see I said about 8 minutes. They got finished slightly quicker than I thought they would. But that's fine. Let me So if we look at my target directory, you'll see that as well as the jar file that it's created, it's also created mic, which is our executable. And we can kick that off and it starts very quickly. Now, the other way to run this would be to So it takes about 10 times longer to start up doing it that way. And we can also Oh, that would explain it because I wasn't putting the right ped in. Oh. So CPU 14.9%, MEM 1.1. All right. I'll get the right head this time. And uses considerably less memory and considerably less CPU. And that, with stuff that works, doesn't actually give you much in the way of demonstration. If you want to get into doing a big benchmarking exercise on running GraalVM in different ways, that's an excellent thing to start doing. In terms of what we've been through, the summary, native Java, it's basically Java compiled to binary executable. So we do an extra compilation step, either hands-on explicitly or implicitly with a single command that takes the bytecode and compiles it to give you a binary executable. That's going to start faster, it's going to consume less resources. That's ideal for cloud native workloads, loosely coupled microservices, serverless. Framework support makes it much easier to use, makes it much more practical. You get out-of-the-box support with Spring Boot 3, and you are welcome, and I'd encourage you to go and try it yourself. I've put the link in there for getting started with GraalVM. Go and try it yourself, experiment with it. Feel free to run it on your OCI images. If you take up the OCI trial, there's an OCI developer image, which I believe has GraalVM pre-installed. So thank you very much. And any questions?
Thank you, Ewan. I think I spotted two on chat, and I see now one on Q&A.
Okay. Maybe
you can have a look on those until I present the useful resources part. So
display is very large, not seen, speaker full screen. I apologize if there was difficulty seeing the screen. Okay.
What we'll do is when we, just to let everybody know, we'll be moving this to YouTube anyway. We'll ask the chap who cuts that code, can he boost the scale of that image first? Okay.
Yeah. Okay. Cool.
No problem. There was two questions, there was quite a lot going on in chat, so not too sure if you want me to read them out or whether you.
Yeah, read them out if you wouldn't mind.
Okay. Just bear with me here 1 second. What utilities have been used here to show the process identifier, class names, etc. within the terminal? Looks very handy for dev engineers. A smiley face. That's from Anthony. I assume that's maybe a joking question, but we'll move swiftly on. There was another one from Esma. Which is the version of Java you can use for native compile? I hope I'm wording that correctly. That makes sense.
Okay, so we have different. There's Graal. Okay, so GraalVM is, as of March, we're going to start aligning the GraalVM releases with the JDK releases. Up to now, we have had different versions that then get a quarterly patch. So I believe at the moment you can do a native compile with JDK 11, JDK 17, I think JDK 19. I'm not sure. I think you can still do it for JDK. I will have to check and come back on that one. It's actually, yeah.
Okay, you can let us know, Ewan, and again we can put some info.
Yeah.
Actually, we can, if you're anybody really needs an exact answer, that we can put it in the public Slack. Ewan, there was a couple of questions I know that you were keen to raise. There's a wall of them after coming in just there a second ago, but I'll let you handle them yourself. But there's probably three key ones that you were saying that is really important to understand. Like, do you have to use framework to build native Java application? That was your first question. You said comes up a lot.
You don't have to use a framework. That's the if you want to just start creating a Java application as normal. So, if you just want to go and write the classic hello world and compile that to native, you can. To do that, you just run the native image command. So there is a separate command that you get with GraalVM, which is just native image, and you run that, and that will then compile your class files or your jar file to produce a native executable. It's like anything else. Frameworks exist for a reason. They exist to make life easier. So if there's a framework there, I would use it. You don't have to use a framework.
Okay, got you. Does native Java always perform? I think you actually answered this in the video, in the demo. But does native Java always perform better than standard Java?
No. What happens? So if you when we've run benchmarking exercises, what you see is at the start. So when something starts up, if you have the same program as native Java and standard Java, the performance of native Java will start fast and it will continue at sort of steady at about that speed. What happens with standard Java is initially it's much slower, and then over time it will catch up with where native image is. And that's as the JIT compiler works out which are the hot methods and compiles those to machine code. And once it's compiled the bits that really need to be in machine code into machine code, then you've got it's machine code to machine code. So native Java doesn't always perform faster, but it does perform much faster at startup.
Okay. Your last question, and there is a good few coming in chat now as well. Just two final questions. For native Java, is there any advantage to using Enterprise Edition over Community Edition of Graal?
If you're using the Enterprise Edition, will deliver better performance. You can also do something called profile guided optimizations, and that means you can analyze how the native Java is performing. You can profile it, and then you can feed that into a subsequent you can go back and recompile with that profiling information and optimize the performance.
Okay. There is a few questions in chat, but I do have one from slide 8. There wasn't seriously a Fortran coloring book, was there? And if there is, where do you get a copy of that?
There was seriously a Fortran coloring book. It was the Fortran textbook I was given. As far as I know, it's out of print. But if you're somebody who learns best through silly cartoons and silly jokes, and I am, then that's great. It's much more interesting than a formal book on programming Fortran. I said about the profile guided optimizations, didn't I, for native Java? You can also do some things with garbage collection with Enterprise Edition that you can't do with, or that you don't get in the Community Edition.
Okay, Viola, did you want to take? Will I keep going, or do you want to?
Let's keep going with the questions, I would say, and cover all of them if possible,
Okay.
and then we end the session with the useful resources and the poll.
Oh, okay, cool. Okay, from Tilo, since the compile steps take quite a long time, is there any way to speed up further compilations, meaning using the preceding compilations as a starting point?
As I say, you can do the, I don't think that the profile guided optimization makes it any quicker. There are some flags that you can set that will make the compilation quicker, but those are generally for sort of development type scenarios. If you're wanting to go for production, then you do the whole shebang, as in don't put those flags on. So there are flags that will speed it up, but you will have a less optimal runtime at the end of it.
Okay, from I hope I'm pronouncing your name, Aritz. Can those dependencies be used now or in the near future with a Spring Boot app? Actually, I don't know whether that was related to something we were demoing earlier on, so I'm not too sure that question makes sense on its own.
Is that a question about the metadata?
Actually, you know what? I'll ask Aritz, if you've got that, if you want to expand on that question, feel free to post it now, or alternatively on Slack, and we can pick it up later on. This is from Amar. I have a Spring Boot, Spring question. Does Spring process dependencies at compile time like Quarkus?
If you're using Spring Boot with the native dependencies, then yeah, it's going to be processing those at compile time.
Okay.
That's back to the closed world thing. You have to build a native image, you have to go and check for the dependencies. So the compilation process starts, and it's static analysis of the code. And so wherever where's your main method, what's called from that, and recursively go through the code, find the classes that are actually called. So if you've got a library that consists of 20 classes, but only 2 of them are ever actually instantiated by the program, as far as the compiler can see, it will only include those two. It will only include those 2 classes, which is one of the ways that it shrinks down. But for dependencies to be included, they have to be either found by the compiler or notified to the compiler at compile time. Once the static executable is built, it is what it is. Okay,
and the last one from Amar, I think it's the last one now. With native images, do we still need garbage collecting?
So within the native image itself, what you get is the code. There's if you like, a snapshot of the starting position of the heap, and there's a really minimal virtual machine that we call the substrate VM, and that runs all of that stuff as a native executable. You can set garbage collection options, or there is some capacity for setting garbage collection options at compile time. But when you go to run the executable, you're not going to be, it's kind of set in stone at that time how Java's going to do its garbage collection.
Let's see if there are any questions on Q&A.
There's two on Q&A.
Yeah, there is one from Aris. I think Ewan already covered this one, if I remember right, on the native compilation.
Yeah, so coherence, Eclipse Link, and WebLogic. So coherence and WebLogic, I wouldn't, if you want to run coherence and WebLogic, they will run on GraalVM in JIT mode. So that's where you just use GraalVM as a drop-in replacement for the OpenJDK. And that will typically improve performance. Coherence and WebLogic, it's typically you're talking about a long-running workload anyway. So that's not necessarily the best fit for native Java. And you know, the nature of coherence and WebLogic, they're not a good fit for native. I did try to run, you know, the classic coherence demo. I've tried running that on native image and it's painful. So I wouldn't go that near, I wouldn't touch those for native image. I would run those on top of GraalVM JIT and they will run faster. The other question, do you depend on Spring Boot for applications? I don't know of anyone in Oracle who's building Spring Boot applications that are, you know, are part of our products. That's not to say that there aren't, because there are a lot of products in Oracle. From my point of view, Spring Boot is something that is very popular with the Java community, and therefore it's on us to work with the Spring project to support and enable the community to use native Java. In terms of projects that Oracle sponsors and or contributes to, we have Helidon, if you've come across that. And we also have Micronaut. And so GraalVM will work with Helidon, it will work with Micronaut. As other people pointed out in the chat, there's also Quarkus, depends on GraalVM. So there's a lot of excitement around native Java, and it's not just tied to Spring Boot. I just wanted to talk about Spring Boot because it's the most popular framework, and we've relatively recently had the announcement that it's now supported out of the box rather than with the Spring Native project. And thank you for Violetta and Tom for giving me the opportunity to come and talk to you about that.
It was great to have you here, Ewan. So thank you very much for taking the time to present to the cloud coaching sessions, for these great demos. And of course, we are keen to see you in upcoming sessions. And thank you all for joining the call and for raising these questions, very meaningful questions. If anyone has more to ask, of course, there is a Slack channel you can always use. And for further information or anything else you'd like to from us, you can use also the email address you see now on the screen. All right, I see some messages. There's a thank you messages. All right, good. So with no further ado, I would like to end this call. Thank you all for being here and see you soon. Bye-bye. Have a great day.
Bye.
Bye.